All right, in this last example in Appendix B, we're going to determine if we can actually solve this using Cramer's rule. Okay, and so really the example subtitle is determining when Cramer's rule does not apply. And the only way that the determinant or that you can't use Cramer's rule is if our D was 0, right? Because if I tried to solve, say, for example, x, and I did d of x over d, the only thing that cannot be possible is d cannot be equal to 0, right? Because if d is 0, or determinant is 0, then that's not possible to divide by 0. So really, that's our only thing that you have to, you always first want to do. I wouldn't, like, if you're going to do a determinant of a 3 by 3, I wouldn't start with d of x or d of y or d of z. Start with d first. Let's find the determinants first, right? So that's 1, negative 1, 1, 3, 2, 1, 2, negative 2, 2. Okay. As long as that's not 0, then you should proceed on. But if this is 0, then you can, well, at least it's not that you would stop and say it's not possible, but you would say that you can't at least use Cramer's rule. You might have to use a different method or something like that. So let's just go ahead and check this out here. Again, to choose any column or any row, I will choose, let's see here, what has more ones? This guy. I just like to choose the ones that have the most ones. It's easier for me. And then you also have to make sure that you know what the pattern is. Plus, minus, plus, minus, plus, minus, plus, minus, plus. So that means I'm going to be using this as my signs for when I do this guy right here. Okay. So let's go ahead and start with the first column right here. So I'm going to cross this guy out, right? And I start there. So I do 1. This is 1, and it's positive, that's fine, times the determinant of 3, 2, 2, negative 2, right? Because that's what's left. Move my little line down. Okay. Now I have 1, but then it's a negative sign. So it's going to be negative 1 right there. So negative 1, multiply that by the determinant of 1, negative 1, 2, negative 2. And last but not least, move that bad boy down. All right. And it's a 2 with the positive, so it's plus 2, 1, negative 1, 3, 2. Okay? So 1 times this is itself, so I don't have to write the 1 right there. So it's 3 times negative 2 is negative 6. 4 times 2 is, or 2 times 2 is 4. This right here is negative 1 times a negative 2 is negative 2, minus 2 times negative 1 is a negative 2. So there's a lot of parentheses going on right there. Maybe brackets would be helpful. Plus 2 times 1 times 2 is 2, minus negative 1 times 3 is going to be a negative 3. A lot of stuff going on there. All right, great. So doing all this right here, this is going to be negative 10. Doing this guy right here, this is a positive 2. So that's 0 times negative 1. So it's just going to be, like plus 0 there. Okay. And this right here is positive. So that's going to give me 6. Or, I'm sorry, 3 and 2 is 5. Plus, or multiplied by 2 is going to give us 10 right there. And what do you know? What do you know? Oops. We have 0. Aha! Kind of the subtitle gave it away. So since D is equal to 0, it's not possible, right? So it's not possible to use Cramer's rule. So we're kind of done with the problem here. Well, not quite really, because, well, what does that mean? Is there a solution? And really, if you kind of look at this, these are almost kind of like similar. If I were to divide this by 2 and that by 2, I would have x minus y plus z equals 7. And these are almost the same, right? These two right here. And if I multiply this side by negative 1 and that side by negative 1, I'll get negative x plus y minus z equals -7. So now if I add these two columns together, sorry, these two systems right here, if I were to add them together, the x's cancel, the y's cancel, the z's cancel, and I'm left with 0 equals -1, right? 6 minus 7 is -1. And we learned from last chapter that we did together that if you ever get something that is not true, it's going to be inconsistent, and the answer is the empty set, meaning that there is no, these don't intersect, there is no solution. So not only is Cramer's rule not possible, but there also are no solutions as well.